Writing quadratic equations in different forms. We have three different forms that we've talked about thus far. We have vertex form, which is the general equation y equals a times x minus h being squared plus k. So you can tell it's vertex form because you have a binomial being squared or an x being squared. Intercept form, which would be y equals a times x minus p times x minus q. Usually intercept form looks like factored form. You have binomials being multiplied together. But remember, sometimes we do have an x along with a binomial where you would rewrite x as x minus 0. We also have standard form, which is y equals ax squared plus bx plus c. Now, if you're given a graph and asked to write an equation, writing it in standard form isn't really ideal because the only thing you get just by looking at the equation is the y-intercept. So, and you could tell the a value as well, but there's no way to really tell the b value just by looking at it. So if you only can find 2 out of the 3 terms, this isn't a very good form to use. Which is why for today's notes, we are only going to write quadratic equations given a graph in vertex form and intercept form today. For vertex form, you need to identify what is a, what is h, what is k, so that we can plug it in. A, you always check from the vertex, if I move right 1, how far up or down would I go? So for this one, if I go right 1, to get to this point, I have to travel up 1 unit. So up is a positive movement. I went up 1, A is a positive 1. H and K come from your vertex. So your vertex in this problem seems to be located at 4, 0. Your vertex is always H, K. So my H is 4, my k is 0. Now that I have a, h, and k, I can plug them into this equation to write my final answer. So for this graph, it is y equals a, which is 1, and you can write the 1 there, you could leave it off, that's up to you, times x minus h, which was 4, being squared, plus k, so plus 0. You could put plus 0 or you could leave it off as well. But this is the equation for that graph. Taking a look at number 2. Number 2, once again, we need a, h, and k. Now this one, if I'm trying to determine what is a, I move right 1 and down 1. So if I move down, that's a negative. The amount was 1, so a is negative 1. H and k come from the vertex. So the vertex appears to be located at -2, -1, which means h is -2, k is -1. I just take these values and plug them into the equation. So I have y equals negative, you could write -1 or just negative out front, up to you, x minus h, so x minus a -2 becomes x plus 2, because 2 negatives makes a positive. That binomial is being squared. Always make sure you're squaring it. And then plus k. So I'm adding a -1, which just becomes -1. And there's the equation for that one. Let's do another one. For this next one, once again, we are going to take a look. What is a? What is h? What is k? Now this one, I move right 1 up 3. So a is a positive 3. My vertex seems to be located at 4, 2, which means h is 4, k is 2. And I'm ready to write my equation. It's y equals a, which was 3, times x minus h, which was 4, being squared, plus k, so plus 2. That is the answer to this one. Let's do another one. Once again, what is a, what is h, what is k? A, I move right 1 up only half of a unit, it looks like. So a is going to be a positive 1/2. H and k come from the vertex. My vertex is 1, 2, so that means h is 1 and k is 2. So my equation is y equals positive 1/2, because a comes first, and then x minus h, which is 1, that binomial being squared, plus k, so plus 2. And that would be the equation right there. Now, I do want to mention a couple of things. Here, the a value is 1. Notice how it's opening up, and it has that pattern, right 1, up 1, right 1, up 3, right 1, up 5. So this has the same pattern as the parent function. With this one, a was negative. Notice that the transformation was a reflection. With this one, the graph is more narrow than the one up here that has that parent function shape. And it's more narrow because 3 causes a vertical stretch. This graph seems wider, and that is because a is 1/2. It causes a compression of your graph. Let's take a look at intercept form. Intercept form is the same idea, A, P, and Q. We need to identify those values. A, you identify the exact same way as what we did on the previous problems. So from the vertex, you go right 1, up 1. So that means A is a positive 1. Now P and Q are your x intercepts. So P, I usually put left to right, so P would be 2, and then Q would be 6. If you let P be 6, Q be 2, that's fine as well. We're going to get the same thing at the end. So now I have y equals, just plug them into the equation. So you could write 1, or you can leave it off. Then it's understood to be 1. X minus P, so minus 2, times x minus Q, which was 6. And that's the answer. Let's take a look at the next one. Once again, what is A, what is P, what is Q? Because we're doing intercept form. This one moves right 1, down 1, so A is negative 1. This one has intercepts at negative 1, positive 1, so negative 1, positive 1. We're going to take these values and plug them into the equation. Y equals A, so negative 1 goes out front, or just a negative, and it's understood to be 1. X minus negative 1. When you subtract a negative, it becomes a positive, so it's x plus 1. And then x minus Q, which was a 1. So this is your equation in intercept form. Let's take a look at this one. For this next one, we are still doing intercept form, taking a look at A. So from the vertex, to get from this point, so right 1 to this point, up 2, so A equals a positive 2. P and Q, P appears to be 0, and Q appears to be 4. So there's two ways you can write this equation. You could do y equals, A goes out front, so 2. You can plug in 0, so you can say x minus 0 times x minus 4 when you plug it in. Or you could have put y equals 2. X minus 0 is just x, so you could put 2x times x minus q, so x minus 4. So this would be an acceptable answer, and this would be an acceptable answer. Let's take a look at the next one. Once again, A, P, and Q. If I move right 1 from the vertex, it looks like I only went up half a unit, so A is 1/2. P and Q, what are the intercepts? It appears to be at negative 2 and positive 2. Take these values, plug them into the equation, so A times x minus, so minus and negative 2 is a positive 2, and then x minus a positive 2 has that expression, x minus 2. And that's our answer.